Hi, I'm Jeff Peoples, Senior Product Manager here at Parasoft, and welcome to Lock and Load. Take aim at performance issues with load testing. A little housekeeping. If you have any questions during any part of the presentation, just drop those into the Q&A box and we'll address those at the end of our session. In today's fast-paced, quality at speed world, companies have begun to realize the importance of adding performance testing to their CI/CD pipelines. Indeed, it's a necessary step in gaining the agility and scalability to move from an automated to a continuous testing practice. As an example, one of our larger corporate customers, Parasoft was able to help them reduce their testing timeline by 27 days. Now, that's not saying to 27 days, that's saying by 27 days. We helped our customers shave 27 days off of their existing testing timeline. And I'm excited today to have the opportunity to showcase some of the workflows and features of one of our products you maybe don't even know about. And the tool I'm talking about that was critical to accomplishing those 27 days is Parasoft LoadTest, which packages with SOATest. So if you already have SOATest, you very likely already have this tool, and you may not even be using it. I'm going to take you through a fundamental demonstration of the tool and the various ways you can slice and dice the test results to suit your specific needs. And then I'll show you some additional tools that push the power of load tests even further to give you a 360 plus view of your testing practice. So if you're ready, let's lock and load. In DevOps environments, it's best practice to run performance tests as part of the CI/CD pipeline. Many teams have realized that a regression in performance can have as big of an impact on application quality as regression in functionality. The problem with the traditional way of doing things is that when we look at the SDLC timeline, we typically see that we have the usual phases. We have design, we have prototype, develop and refine, test, and then implement or deploy. And where does testing come in? Unit testing traditionally began right after development, but before actual QA functional regression testing. Where then would performance testing fall in the old model? Well, if at all, just before deployment, the very last step before rollout. And I'm sure we've all experienced the pain and resource issues of finding an unforeseen problem either just before or worse, after rolling a product into production. So how do we avoid that? What if you shift load and performance testing to the left so that it becomes part of functional regression testing? Make it part of the early stages of the development process, and then leverage this early feedback loop to find and fix performance issues iteratively so that by the time it reaches deployment, you know your product can handle not only the expected daily loads, but the massive Black Friday type onslaught loads as well. So what does it take to achieve shift left performance testing in your organization? As is true with any organizational change, the stakeholders and leadership have to be behind this new paradigm, as this could likely be a total organizational change. We recommend defining then quality of service agreements at the component levels of your application, and I'll go into why this is in a moment. And then we suggest shifting focus from UI testing to API testing. And the last step, once you've achieved those other steps, is making performance testing part of your CI/CD pipeline. The very first step in moving from a manual to automated and further from an automated to continuous testing requires full company buy-in. Many company structures may be siloed or have QA departments that only handle performance testing, or one department may have a "that's not my job" point of view. But wouldn't it be great to see newly developed releases flow smoothly through the SDLC without any regressions that hold up production rollout? We're talking about what could be a fundamental organizational change that stakeholders agree to endorse. The foundation, therefore, is organizational buy-in. The next is know thyself, or know your application's response times, CPU and memory usage, etc., at the component level. And you can then define quality of service metrics for each of those, or how you want to measure performance and the minimums and maximums you're willing to accept. And from there, you can specify thresholds that determine whether a test passes or fails. The third step is to migrate your testing practice from purely browser-based testing. No, we're not saying don't do browser-centric testing. What we're looking at here in the dark blue is the testing pyramid. And the little person at the top represents manual testing, and below it is UI or browser-based testing. These are the smallest on the pyramid, as they should have the fewest tests. UI tests are slow and time and resource consuming to maintain, whereas the lower automated layers of the pyramid show where the majority of tests should be performed, with unit testing as the foundation through component testing and integration testing up to API testing. But the gray martini glass shape is what we tend to see in organizations today, where the majority of their testing is performed either manually or at the browser level, with only a small amount by comparison of API, integration, component, and unit tests. So step 3 is shifting focus from browser-centric testing to include primarily API and database testing. And lastly, you need a tool that integrates performance testing into your continuous integration process, so that as the developer checks in their code, the CI process kicks off, performing smoke tests or baseline sanity check tests. And then a more extensive battery of performance tests should run against the newly incorporated build on a nightly basis. So what are the top 3 challenges to implementing performance testing? The first is cost. Performance testing has a traditionally specialized skill set requirement, and the tools and the infrastructure to pull it off have been prohibitively expensive. Without the ability to automate and virtualize performance testing, you'd need hundreds of machines and hundreds of testers to simulate loads you'd experience out in the wild. The second is the difficulty testing across the entire environment, running into issues with systems being unable to communicate due to non-standard messaging protocols. And again, we are faced with the resource and the knowledge and the specialized skill sets. And also, creating scenarios requires correlation across all those teams. And the third is the inability to correlate the scenario to the user story, so that when an issue is found, there's not a link to what changed to go fix that issue. So bottlenecks, time loss, and thus everything becomes a fire drill. Okay, so what then do we need in a tool that will help us enable us to shift our performance testing left? First, we want early notification of potential performance issues. And an ideal time is after we've checked in our code changes and we come in the next day and we find where a potential performance problem exists. We want to be able to create predictable, scalable, synthetic load of virtual users. Or we could create our load with hit rates. Our virtual servers are hitting the servers such as hits per second or hits per minute. We want to be able to run anytime, anywhere by virtualizing dependencies. So we're not just limited to when dependent systems are available to us. And lastly, we want to be able to run performance testing continuously in our pipelines that require no setup or any human interaction. So when we're talking about performance tests, what is it? What do we mean when we say performance testing? So if we look on a graph with the x-axis being the duration that the load is expected to run, and the y-axis is the amount of load, then the first test that is logically run, and I mentioned it, is the smoke tests. And smoke tests are run as essentially sanity checks that the system meets the minimum requirements. And these are generally quick tests that are often included as part of a continuous integration process that just ensures that the application meets minimal standards. Next is stress testing, which is basically increasing the load until something breaks. These types of tests are normally used to understand the upper limits of capacity within the system. And this kind of test is done to determine the system's robustness in terms of extreme load and helps application administrators to determine if the system will perform sufficiently if the current load goes well above the expected maximum. Next on our load continuums, we have load tests. These types of tests are usually performed to determine if the system can withstand expected common daily level loads over expected durations. Load tests are used to answer the questions like, does our application meet those quality of service indicators we defined? Or has a change been made somewhere up the chain that causes our system not to perform as expected? And then we have soak or endurance tests. And these tests are usually performed to determine if the system can handle an expected load over a continuous, sustained duration. During soak tests, memory utilization is monitored to detect potential leaks. Also important, but often overlooked, is performance degradation, i.e. to ensure that the throughput and/or response times after some long period of sustained activity are as good or better than at the beginning of the test. Which brings us to our demo. So now I'll just flip my screens here. So I'm going to begin our demonstration with that shift left performance testing step 4, showing you how easy it is to integrate performance testing into your CI/CD pipeline. First, just a high-level overview of the setup, and then we'll delve deeper. Our journey begins in LoadTest. The first thing to do is to create a functional API test suite that sufficiently tests the aspects of your application that you want to use as performance tests. And you could have created this test any number of ways. But our goal for this demo is to show you the simplest case we could come up with so that you could get an idea of all the components of what I'm going to show you without getting caught up in the complexities of a more involved scenario. In this case, ours tests a demo calculator service created for such a purpose. So whatever way you created your test, performance testing begins with a suite of tests. And here we have our calculator test. And we see it has separate tests at the API level for addition, division, subtraction, and multiplication, all in this one TST. The reason this is red is because I've implemented a failure condition in my multiplication operation. For what I want to show you, it's more interesting to see passes and failures than just green across the board. So, one TST file with 4 tests. Simple. So once we have our TST created, we're done with LoadTest for now, so we'll minimize that. You may have noticed this additional icon that installs when LoadTest installs. This is Parasoft LoadTest. So you would double click this icon to start LoadTest, which I've already done and I have running here, where this is the LoadTest UI. And I have open my LoadTest project that I created from that calculator TST. This UI is where you'll collate all your machines that are running LoadTest in server mode, and I'll go into that in a second. The UI is also where you'll set up those quality of service metrics that we talked about and turn them into pass-fail criteria. And we can also set up monitors that are watching and reporting on the metrics that you specify. So first up, we want to set up our machines. And this is the first node that we have here. I want to draw your attention to the machines we have here. all you need to do to set up any machine with LoadTest installed, you can just type LT minus LoadTest server or dash LoadTest server, either from the SOATest install directory or include the path. And this can be on any remote server that your desktop has access to, including compute instances on the cloud. And here, Parasoft even has AWS machine images, or AMIs, that are pre-installed so that when you spin them up, they're instantly running the LT command. And all you then have to do to incorporate this into your list of machines is point the LoadTest controller to your AWS IP address. So now that the server is up and running, I just need to come back to my LoadTest UI and right-click on my 8189 server and say verify. And so now we see that we have two servers that are green and ready to go. But before I define my synthetic load, I need to tell it what I want LoadTest to watch and report on. And so to do that, I need to set up my monitors. And so I'll just click here. And so we can see that I've come here and created two custom monitors where I'm saying I want to watch my available memory and also my CPU processor time. And if you want to add any new ones, you would just add new ones at this button. So now that we've determined what we're going to monitor, we want to establish the profiles of our virtual users. Okay, so to the right, we see the tree of my TST suite that I created in SOATest. And the system has already generated a user profile for each test. And these are indicating a type of virtual user that LoadTest will generate. In this instance, my add user, who will perform testing on my addition operation. But if I wanted to, I could say my selected profile could perform other tests in the suite. I would just have to put a check in that box. So now that we have our profiles defined, we need to tell LoadTest what our quality of service thresholds are for those monitors that we created. And so to do that, we move on to scenarios. Now, our scenarios node has a twofold purpose. And the first is to define quality of service thresholds. And the second is to establish the actual shape of what we want our load to look like. And I'll explain what I mean by that in a second. So let's start with quality of service. Here we define pass or fail criteria that determines the thresholds that we have specified. And I can set these up by just with this details here, where I would just click on it and then specify. We can see that even though these 5 that are created immediately by the system, they're also editable as well. So once I've moved on, once I've defined my QoS, I then can move on to my steady load scenario itself. Now the term steady load is referring to the default shape of the load I'm going to create. So for instance, if I were just to right click on scenarios here and say new scenarios, this is how I would create a scenario. And we see that I have these various shapes to choose from. And so we see linear increase, which looks a lot like that stress test we talked about. Steady load is the one I have. Bell, or what's also known as a spike test, or I like this one, a buffer test, which is just extreme load, minimal load, extreme load, minimal load. And but for the sake of this one, we're going to look at steady load, which is just a steady load all the way across. And that's what this one began as, but that's just how the shape begins. And you then have the ability, you can come in here and right click and then say add a point. And then I can then take my point and move it around, and I can change the structure of this shape so that I can say for my control parameter number of users here, I want to ramp up and then drop down, or however it is that I want to adjust my load. I also have the ability to not only control the parameter of number of users, but I can apply these line shapes to say that I want, instead of number of users, I want to ramp up my hits per second and all the way up to hits per day. You can also specify weighted profiles, which basically says from across my servers, weight my profiles according to however I've specified with these loads, or you have another option to choose direct profiles, which allows you to specify shapes for add, divide, multiply, whatever your profiles are. So at this point, all we would have to do is click Run Scenario. And after my scenario initializes, it's going to bring up real-time graphs of the metrics that I'm monitoring. And I have the ability to right-click here, and I can change my layout if I want. I have my 4, and these are graphs that are real-time tracking the monitors and the metrics that we told it we wanted to watch. And you can modify these graphs and add lines or add metrics to them, or I can right click here and view my layout and choose a 3x3 split. And then I have these extra graphs that I can build information on my own. And I would just do that by by clicking this button here. And then I can select virtual users, for example, and then I can filter. I can view all machines, or I can view a specific machine, and then I can view all profiles or just a single one. So like that, and then close that. And now it's telling me, so this is what the average of the two machines looks like, whereas this is what my single 8189 server looks like. And so these will just process, and as this runs, when it completes, it's going to generate a report. And I've already pulled up one of those reports here, so I can just show you that one. Just click load here. And so this is what the report looks like. And we see here that we have our QoS metrics, and we have our pass or fail status, and then we have the details of those that occurred. And then we have our load test configuration, where we have which servers we're running, and then the profiles that we've specified in our test. And so this report also features 4 different views. There's the summary, which is what we're looking at here, and then there's statistical view as well, where you can view just the generic statistics on the tests, or you can drop this down and view the network client reports, which provides information like send time, receive time, ping time, etc. I also have a detailed report where it's graphing out for me how the particular, whatever I have checked down here, whichever monitor I've checked here, okay, it's now finishing the test, and it's building a new report. So let's go back. Let's just go ahead and stop that. So, okay. And I can also view the individual hits. And so this is what it looks like if I had just captured the green ones, the successes. But like I said, it's more interesting to see the red and the green together. So here I have the ability to, I can highlight some data that I want to look at, and then right click it and I can view those individual hits and all the data on them. And I can also just double click here, or actually let me, if I double click here with a multiply, I should see export the hits of this view. And I can save those to a file. So I can just get the information that I need, however detailed I want to get for each of the data points that I want, or like I had, I can view them just in summary. And also we have our quality of service report, where we have both the pass and fail status of those quality of service metrics that we created. Okay, how are we doing on time here? Okay, great. So the next thing I want to show you is that LoadTest obviously has all of this robust information and reporting tool, but it can also simply just, all you do is your setup here, and then you can use it as just a setup tool to run performance testing in your CI/CD pipeline. And so here I have just a DOS prompt where this will be my simulated CI/CD pipeline, which basically just enables me to run load test from a command line. And so all I would need to do that is I'll just reference the same LT command, but now I'm referencing a CMD file, a calculator command. And so that's all it takes for me to run this in CI/CD. So I would just run this. And while that's running, let me go into a little detail about the CMD file. This is a CMD file that it's calling, and we see here there's nothing complex about it. It's just specifying where our test route is and what tests we're running, and then what scenario inside that test we're running, and also the directory that it's writing out any reports to. So if we were to navigate to that report and pull it up, we basically would have that same report that we saw, except now it has additional, now it will have an additional, where is it? Sorry. Oh, no, that's the wrong button. Okay. It would be this same report, except now, because it doesn't have the benefits of all this UI stuff, it would just be this report here, and it has an additional section that has our statistics. The second major player that I want to show you in shift left of performance testing is LoadTest Continuum. Now, Continuum is a web-based application that accumulates load test results each time they're run. It then generates dashboards with charts and graphs that further analyze those results over time. LoadTest is for setting up, configuring, executing, and analyzing a specific performance test run, while LoadTest Continuum is for analyzing multiple runs over a span of time, and all through a web-based interface. You'll be running your load tests daily, and what you want to see is whether the test succeeded or failed, as well as either the standard or custom metrics you defined in LoadTest. Continuum integrates seamlessly with a plugin where you can see the passes and failures, and when you click the link, it takes you to the details here in Continuum. And you can drop these down and get further detail. And for instance, I can click this icon for, let's look at, let's say, hits per second. And so this gives me all the graphs that are associated with this particular metric. And so if I just double click right here, I see here that I have my graph, and I can view the last week, I can view the past 30 days, or So for instance, like if I click my week, I can then use my navigator down here to just page through to view the graph, whatever portion I want to. So that would be load test continuum. In review, we looked at the challenges organizations face when shifting performance testing to the left. So, of the cost issue, we can solve it by simplifying API test generation to reuse functional tests that were already created and then run them as performance tests, and then establish load test servers on the cloud instances to save on infrastructure costs. We can solve the complexity of performance testing by shifting the focus from UI to API testing. And we can use service virtualization whenever necessary, such as when a live asset is constrained, costly, or unavailable. And then we can use load test to generate a synthetic load in these dynamic testing environments. And finally, we solve the correlation issue by associating performance tests with requirements. We define your criteria for pass-fail as part of performance testing itself, and then we run it all continuously as part of our CI process. Further, we touched on what we need in a tool in order to shift performance testing left. We need early notification of performance issues. We need the ability to generate a predictable, scalable, and cost-effective load. We need the ability to test anytime, anywhere. And we need the ability to run continuously. And when you want to run it continuously as part of a continuous nightly process that requires no human interaction. And I showed you how these all could be achieved by setting up remote servers simply by using the LT executable with the load test server flag, or by running the tests themselves using the LT executable from the command line. You also have the load test UI to do all of your initial setup, where you can reuse functional tests you've already created in SOATest. You're able to collate and control the states of those remote servers you set up. You can define user profiles at the project level and determine which user profiles will run which tests. And you can even take it a step further with scenarios in which you specify the ramp up, stabilized, or ramp down, not only the number of users, but also hits per second, per minute, or hour of the day. Or if you like, you can randomize any of those variables. And you can create your own metrics and monitors of those metrics, where you define component level QoS metrics that become pass-fail criteria. And then you can track those metrics over time and collate them from across multiple machines that are generating those virtual loads, and get reporting, graphs, and analytics using load test continuum in a time-traveling 360-degree bird's eye view. And I think that's about all I had planned to show you today. So we can go to the QA box to see if we have any questions. So let me just do that briefly. Okay, how can I troubleshoot if a test fails? Okay, let's go look at that one. Okay, that's the other one. Okay, so how I would troubleshoot if a test fails. First of all, we have the ability here is to create our report composites, where you have the ability to monitor multiple reports together. And I would just right click here and say load all. And then I can view these in various ways. I can view my statistics, and the statistics can help with the debugging, with troubleshooting, as well as the detailed report where you can specify those individual hits. Now, you can actually change how those, in our scenarios master node here, this is where you can specify whether you're going to record the first 50 or whether you're going to record just the error. But you can select and record all of them if you have like the disk space. But the idea is to just record. You can record just the first however many number that you select, and you can view just say collect the errors and don't worry about my successes. And so that's another way of debugging that. Here we're looking at just the failures, and I have the ability, I can double click on these. They're sometimes hard when they're so small. Let me widen it a little bit, and then I can hold my shift key down and I can pan around, and then I can, so here would be an error that I can then double click on, and so it could give me, I can come down here. So it says the connection timed out. So it gives me the error message to help me find what the problem may have been. Okay, so let's go back. Okay. If I'm recording my hits, how do I ensure I don't run out of disk space? Okay, so in that same scenarios tab that I showed you there, not only do you have the ability to say only record my first 50 either errors or successes, but instead you can say instead use K bytes, and then you're actually determining what the disk space is, and then you can limit the amount of data you retain based on just disk space. Okay, and okay, and is hits per second the only thing to use? Okay, so what I think what they're asking is, in my load scenario, down here, just to review this, I can set the load shape to say ramp up in the first 15 seconds, ramp up to 10 users here. Or I can also say, drop this down, and I have my choice of changing that load to say, instead of ramping up my users, ramp up the amount of hits per second that my user is performing. And so we have that way to modify the load shape. Okay, so that looks like about it. Let me go back to my screen. For more information, check out our website, or you can just scan the QR codes that you see here, and visit our website for these and other informative white papers, articles, and don't forget our blog. Thanks, and have a great day.